Hey there, today we are tackling a classic programming puzzle that's all about finding pairs of numbers. Ones that add up to a specific target. It seems pretty simple on the surface, but figuring out how to do it efficiently, well, that reveals a really powerful technique that can make your code so much faster. Let's jump in.
To get us started, just imagine this. You're at a massive party, and your job is to find pairs of people whose ages add up to exactly 100. How would you even start? This is basically the same puzzle we're solving today, just with a list of numbers instead of a room full of people.
So here's the official challenge. You're given a list of numbers and a target value we'll call k. Your mission is to sift through that list, find two numbers that add up perfectly to k, pull them out, and count that as one operation. The goal is to find out the absolute maximum number of times you can do that. The best way to really wrap your head around this is to just see it in action. So let's dive right into our first example.
Okay, here's our setup. Our list of numbers is super simple. 1, 2, 3, and 4. And the target sum we're aiming for, our k, is 5. Looks pretty straightforward, right?
So let's start looking for pairs. Right away, you can probably spot that 1 plus 4 equals 5. That's a match! So we count that as one operation and pull them out of the list. What are we left with? Just 2 and 3. And hey, would you look at that? 2 plus 3 also equals 5. That's our second pair. The list is now totally empty, so we're all done. And there's our answer, a maximum of 2 operations. Now, in this case, it worked out perfectly. We paired up every single number. But as you're about to see, it doesn't always go that smoothly. Now, when you first see a problem like this, your brain probably jumps to the most direct, obvious solution. So let's talk about that first instinct, the approach we call the brute force method. The obvious way is to just, check everything. You just grab one number from the list, and then you try to pair it with every single other number that's left to see if you get a match. So the logic goes something like this. You take the first number, 1. Then you check it against all the others. Does 1 plus 2 equal our target of 5? Nope. How about 1 plus 3? Still no. Okay, 1 plus 4? Yes, we found 1. So you count it, you remove both of those numbers, and then you start the entire process all over again with whatever's left in the list. But here is the massive problem. This works okay for a tiny list of 4 numbers, but can you imagine a list with thousands of them? This method gets unbelievably slow. It's just like that party analogy. It's like forcing every single person to meet every other person one-on-one. It's just a huge waste of time and energy. And this slide just perfectly sums up the difference in thinking. The hard way is stuck asking this repetitive question over and over. Does this plus that work? This plus that? The smart way asks a much, much better question. For the number I'm looking at right now, have I already seen the number it needs to make a pair? So how do we actually ask that smarter question? Well, we need a secret weapon. And in programming, that weapon is very often a little something called a hash map. Now, don't let the technical name throw you off. A hash map is just a super clever tool that basically works like a perfect memory. You can give it a number, and it can tell you, like instantly, yep, seen that before, or nope, that's a new one. It's incredibly fast. All right, so let's actually see how using this perfect memory totally changes our strategy. We're going to run through a slightly trickier example to see exactly how this works. Okay, here's our new list, 3, 1, 3, 4, 3. And the target sum k is now 6. And you'll notice we've got a few duplicate numbers in there this time, which definitely makes things a little more interesting. So we're going to go through this list just one time. We start with the very first number, which is a 3. Now, to make our target of 6, what does it need? It needs a partner that's also a 3. So we check our perfect memory. Have we seen a 3 before? Right now, our memory is empty, so that's a no. Okay, no problem. We just add this 3 to our memory and move on to the next number. Next up is the number 1. To make 6, its partner needs to be a 5. We do a quick check of our memory. Have we seen a 5 yet? Nope. All right, we just add the 1 to our memory and keep it moving. Okay, now this is where the magic happens. We've just arrived at the second 3 in our list. To make our target of 6, what does it need? It needs a partner 3. So we ask our perfect memory, hey, have you seen a 3 before? And this time the answer is, yes, we have. We put one in our memory way back in step 1. We found a pair. And boom, that is one successful operation. We add 1 to our counter. Now this next part is absolutely crucial. As soon as we use that 3 from our memory to make a pair, we have to remove it. Why? because this makes sure we don't accidentally try to use it again later. It's been used, it's gone. Then we just keep this process going for the rest of the numbers. So we've seen two very different ways to get to the same answer. Let's just wrap things up by talking about why that second method is so much better. Here's the big takeaway. The brute force method, yeah, it's simple to come up with, but it's painfully slow because it does so much work over and over again. By using a hash map, our perfect memory, we completely avoid all that wasted effort. We only have to go through the list one single time, which, for a huge list, is just a game changer. This idea of using a little bit of memory to save a massive amount of time is a core principle in writing really smart, efficient code. And that really leaves us with a final thought, doesn't it? This whole pattern of remembering what you've already seen to make things faster shows up absolutely everywhere, from finding duplicate files on your computer to how recommendation engines work. So what other real-world problems can you think of that could be solved way faster just by having a perfect memory?